All right, everyone, let's get started. This is your last homework number 9 for chapter 7. In this lesson, number 99 right now, in this lesson, you discovered that the mid-segment of a triangle, the one that you guys did on Desmos today in class on your Chromebook. So you discovered that the mid-segment of a triangle is not only parallel to the one of the sides, but it's also half the length of the side. But what about the mid-segment of a trapezoid? Okay, so down below, right here, that's a trapezoid. Okay, the diagram on the right shows a mid segment of a trapezoid. That's EF. So this is the mid segment of this segment and this segment. So that's what it means. Because point E and F are both mid segments of the non-base sides of the trapezoid ABCD. Okay, so what are we doing here? Let's see. It says if A equals 0, 0, so A is 0, 0. B equals 9, 0. C equals 5, 6. And D equals 2, 6. Find the coordinates of E and F. Okay, so E, and you should have learned this today, right? If you graph this on a nice, perfect grid, you will be able to see it. But you should have learned today that to get the X value, you're going to take the 2 and the 0, and you're going to add them. So 2 plus 0 is 2. And then you're going to divide it by 2 because you want the middle of it. So 2 plus 0 is 2. Divided by 2, you get 1. So the X value is going to be 1. To find the Y value, you take the Y's, right? 6 plus 0 is 6, and divided by 2 because you want the middle of it. So that's going to be 6 divided by 2 is 3. So this point E is at 1, 3. We're going to do the same for point F. I'm going to go 5 plus 9 for the x's. So 5 plus 9 is 14. And 14 divided by 2 gets you 7 for the x. And for the y, you're going to go 6 plus 0 is 6 divided by 2, you get 3. Right? And it actually makes sense that it actually, look at both the y's, they lined up because this is perfectly straight across. So it's up 3. So it actually does seem like it works. Okay. Okay. So find the coordinate of EF. So E and F is 1, 3, and F is 7, 3. And what's the length of the mid segment EF? Okay, so because this is flat, it's actually easy to count. So from 1, you're gonna go all the way to 7. So 1, 2, 3, 4, 5, 6, 7. So how many jumps is that? Right? And that's gonna be 6. So this length right here is gonna be 6. So this is gonna be 6 long. Okay. And then I want us to compare the length of the bases AB. So AB, right, how long is AB? Right. Well, AB is a straight line, so it's flat as well. We're going to go from 0 all the way to 9. So guess how many is that? Yeah, it's 9. You count from 0 to 9, you get, or 9 minus 0, you get 9. And then you're going to go ahead and do DC, and it's going to be from 2 to 5. And you can't even figure that out, right? From 2, how many more to you get to 5? Or you can go 5 minus 2, and you get a length of 3. Right? So comparing 6 to 9 and 3, right? Compare these three. And actually 6 is right smack in the middle between 9 and 3. So what's the relationship amongst the segment? Right? So we want to say, let's answer the question first. So the coordinates of E and F, right? Find the coordinates of E and F. So we want to say E is going to be 1, 3. and F is going to be 7.3. Okay. Then compare the length of the, what's the relationship? Right, so the last part is what's the relationship amongst the segments. So we want to say um, mid segment EF is exactly in between that should be capital I, in between the lengths of DC, which is 3, and AB, which is 9. Right, and if you want to do this, you can even say 9 plus 3 divided by 2 equals 6. Okay, verify the relationship you observe in part A holds true for, okay, so they want us to do this again, except this time they want us to use different points, and we'll see if that actually works, right? So they want us to use different points. That was fun, right? Okay, so for part B, they want us to use A as -4. Sorry, I want to use -4, 0. B is 2, 0. C is 0, 2. And D is -2, 2. Okay. And you don't even have to do, I mean, a lot of the time you can just think about it, right? E is in between, right? And we're looking at X. So between -4 and -2. One number is in between -4 and -2. Right? Well, E is -3, right? But if you don't know what number is between -2 and -4, then you can just go -4 plus -2, right? Get the answer and then divide it by 2. So that's -6 divided by 2 is going to get you -3. So we can find that out anyways. Okay. Then you're going to do the second part. What numbers between 2 and 0, right? And that's the y's, and we're talking about 1. So E is -3, 1. Again, if you don't know that, you can just go and add both numbers. Right? You can just add 2 plus 0, and then you're going to divide it by 2, and you get 1 anyways. And that works out. Okay. Okay. Then you're going to go ahead and, wrong one. Or I need to do a different one. Right. Now you're going to need to find the midpoint or what the location of F is. Right. And we're going to do the same thing. For the X, we're going to, different color. For the X, what's between 0 and 2, right? What number is between 0 and 2? And you probably know that that's going to be 1. Right? But again, you can go 0 plus 2 is 2. And then divided by 2, you get 2 over 2, which is 1. And we got that anyways. Right? And then you can also do, for the Y, you're going to go 2. What number is between 2 and 0? Okay. Well, between 2 and 0 is 1. So that's the middle. That's the midpoint. But again, you can also do 2 plus 0, right? Which is 2 divided by 2, because you want the middle, that's 1. Right? So we have our coordinate. And let's verify this, right? So let's count. From -2 all the way to 0, how long is this piece? Right? Yeah, I mean, from -2 to 0, this piece is 2 units long. And then from -4 all the way to 2, how long is this piece? Right? So you can go from -4 on a number line. Right? Here's 0. Here's 2 right there. And here's -4. Right? How long is it between -4 and 2? Okay, what is this distance here? Right, that's 6. So this distance is actually 6. Right. And again, so let's check out the mid line, right? Or what do they call it? Mid segment, right? So between -3 and 1, or not between, but how far is it between -3 and 1? If you're not sure, draw a number line. Here's 0, here's 1, here's -1, -2, -3. We want to know how far is it between -3 and 1, right? And you might have guessed this is going to be 4. Right? This distance, that's 4. Okay. And so verify this, right? Does it hold? Is 4 in between 2 and 6, right? Is it perfectly, exactly, right? Here's the word, exactly in between the length of 2 and 6, right? And you can also do 2 plus 6 is 8 divided by 2, 8 divided by 2, and that's going to give you 4. So that actually works out as well. Okay, so verified it. Yep. Write a conjecture about the mid-segment of a trapezoid, right? So I'm going to say the, or lowercase, mid-segment of a trapezoid is exactly, I'm going to write down, is exactly um, the number or the length in between the lengths of the two bases, or we'll call them parallel bases. Okay, because, so what we're saying is that the length of this middle piece is going to be exactly right in the middle between the length of this and this line. And these lines are parallel because you can see they even drew little arrows on it to show you that they're going the same direct. They're parallel. Those those arrows on those two lines mean that they're parallel. Okay, or you can write it something similar. That's not gonna be exactly like how I wrote it. Okay, that one was tough. Okay, there was a lot to it, even for me. On graph paper, connect points A, B, C, and D with the coordinates to form quadrilateral ABCD. Lori thinks the shape is a parallelogram, meaning that the opposite sides are parallel. Verify Lori's idea by finding the slope of the opposite side. Okay, you're going to need to do your x and y axis. Let's see. These points are all positive, so I'm going to go ahead and just do this. Here's my x-axis, and here's my y-axis. Okay. So I'm just going to go, let's see. The x the biggest number is 5, so, and the y, the biggest number is 3, so that's fine. So I'll just go 1, 2, 3, 4, 5, and then the y 1, 2, 3. Okay, so my points: A is 1, 1. That's 8. B is 2, 3. C is 5, 3. Oh. And D is 4, 1. Okay, so they want us to verify that this four-sided, we call it a quadrilateral, is a parallelogram, meaning that opposite sides are parallel, right? So if to figure that out, if we look at BC, right, what's the rise and what's the run, right? So from B to C, if you look at from B to C, so B is 2, 3, and C is 5, 3. Notice how the y's are both 3's. So when I do the slope there, okay, and this is using Evie's method or Miranda's method. If you're period 1, it's Evie's method. If you're period 4, it's Miranda's method, right? So the slope is going to be the y's minus the y, so 3 minus 3, and then the 5 minus the 2. Right? And you get 0 over 3, which is 0. So slope is 0 for the top one, right? Slope is 0. And this equation, or this line at the bottom, okay, and A is 1, 1, and D is 4, 1. We're going to use Evie's method or Miranda's method again. Okay, so the slope for this bottom one is the y minus the y, so 1 minus 1, and the x, the 4 minus the 1. So we get 0 over 3, and the answer is 0 again. So these two, the slope is the same, so now we can say that these two are parallel, and we're going to put a single arrow to show that they're actually parallel. Now what else do we do? Well, we got to do the other one. Okay, we got to do AB. Right, so AB, the slope, and we could use Evie or Miranda's method. Right, so that one I'll do on this side. M equals, so that's gonna be the y minus the y, okay, because we're going from A to B now, or B to A, doesn't matter. So we're gonna go 3 minus 1 over, then we're gonna go 2 minus 1. 3 minus 1 is 2, 2 minus 1 is 1, so the slope is 2. Okay, and let's check out this other side right here, from C to D. Okay, and we're going to do the same thing using Evie or Miranda's method. So we're going to go 3 minus 1 over, then we're going to go 5 minus 4, because we're doing the x's. 3 minus 1 is 2, 5 minus 4 is 1, and your slope is 2 also. And these two do match. So that means that we can now show that it's another parallel line by doing a double parallel line. Okay, like that, because these go together. Okay, if you do a single one, that means that it's parallel with the reds. And we don't want that. Okay, so that's verifying it. And we did this by finding the slope of the opposite side. Okay, and I believe this is the last one. Where do the graphs of the two functions intersect below? Right, so these are both f of x equals, right? And you may not know this. Well, you know now, but f of x is just a big fancy way of writing y. So y equals 4x minus 3 and y equals 9x minus 13. And if we want to find the intersection, all we have to do is just solve the system, right? We can graph it. We can do equal values method. We can do elimination. We can do substitution. Okay, whatever. But since both of these are equal to y, I'm going to go ahead and set them equal to each other. So I'm going to say 4x minus 3 is equal to 9x minus 13. Okay, and then I'm going to go ahead and solve this. So I can probably do two moves at once. I'm going to go ahead and minus 4x, and those will cancel. And then I'm going to do this a second move. I'm going to go ahead and go add 13. Add 13. So these are going to cancel. Okay. So what do I have left? Well, I have negative 3 plus 13 is positive 10. And I got 9x minus 4x makes 5x. Okay. I'm just going to go ahead and finish it off by dividing by 5. And that's going to cancel. And I get my answer of x equals 2 for the x value. So that means that this graph is going to intersect at x equals 2. We still need the y. So we need to go ahead and use either one of these. Okay, I think I'm going to use a top equation because the numbers look smaller. So that's going to be y is equal to 4. And then instead of x, I'm going to put in 2 because I found out x was 2. So instead of 4x, I'm going to put 4 times 2 and then minus 3. Don't forget your minus 3. So minus 3. Right? And y is equal to 4 times 2 is 8 minus 3. So y is equal to 5. So we know that the answer is 2 comma 5. Okay? That's the intersection point, and that is a wrap.